Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Navigate document embeddings with Nomics Atlas. Be the captain of your documents and ML model. Before I dive into the benefits and the features of this vector store, I would like you to visualize for a moment about the existing vector stores that you are using currently. Most of the time, what we do is we start with a bag document, that is a text document. We split it into smaller chunks and then we do the embedding and then move that embedding along with the text into the vector store database. This is the pipeline that we follow. And once that we move the vectors, that is embeddings and the text into the vector store, next what we do is we will try to use vector search to search the vector data store. What if I told that once you move all the data along with the text and the embeddings into the vector store, you can visualize? Will you believe me? If you have been following up with my various discussions till date, in my playlist I have been discussing about working with vector stores, especially working with BERT topic, etc. So if you go to this particular playlist, and if you look at the topic modeling videos, then you will actually understand that there are open source topic modeling library called as BERT topic, and I have taken a detailed discussion on the topic modeling in these 3 videos. The point I want to make here is that whatever you are doing, the topic modeling that you are doing here is done automatically, and the visualization that you look at get in this topic modeling is provided by the Atlas, that is the Atlas vector store by Nomic directly. So that is how you actually interact with it. And this particular map that you're looking at, it's called as a map, and you'll see that once I start hovering over the scatter plot, you'll see that I'm getting the data, the text data that is available on top of it, and you'll see the topics are also available on top of it. Not just that, you can actually interact with this by selecting like this. And once you select it, this entire series of points that you have selected actually gets collected in this place, and you can actually take a look at these data here also. Okay, so yeah, this is what Atlas is capable of. I'm just showing you the basic features in a visual fashion. This is inside the Jupyter Notebook. If you want to get access to this in Atlas own website also, you can get the access. So this is actually an Atlas website, and if you do the same thing here, you will again see that it gets selected and you can actually connect with it. And not just that, after you select it, you can actually tag this and you can start tagging this location into a particular topic. All these things are possible. Okay, now the point here is, let me go back to the presentation. The point here is why we have to visualize. So first of all, you might be thinking, Kamal, why do we need to visualize? What is the benefit of why working in 2-dimensional is better than working in n-dimension? So all these questions will arise because if you guys are following the various, if you have already done embeddings, you will know that OpenAI's embedding is 1536 vectors long. And if you take any of the open source and Google's Palm embedding, it comes at 786. All these things actually have least amount of impact once the embedding vector length is converted to a lesser dimension, that is 2 or 3-dimensional vector space. So that is what Nomic does, and all these things are done at very high speed. So let me go back to the browser for a moment. You see this particular map. This particular map was created in less than 12 seconds. It's actually very high speed algorithm that Nomic is using, and that algorithm is actually closed. So you cannot get access to the algorithm where this particular embedding is getting populated as a scatter plot. Okay, the embedding algorithm, the process of embedding, everything is open source. Okay, only thing that is closed is how this entire embedding gets plotted like this in scatter plot, and also how the topic is getting modeled, because if you take a look at it, if I zoom out, the topics actually vanish. Only the topic that is matters the most stays in the display, and the rest of the topic vanishes. And you see, this is the maximum zoom out I can do. And if I zoom in, so you will see immediately I am able to get the internal details, internal topics also. So this is happening because there is topic hierarchy. All the topics have internal subtopics. So that is how they are able to build such kind of a topic modeling visualization. So for an example, if I take this and if I start building, if I create a cluster around this like this, and you will see that this particular, excuse me, just a minute. Yeah, so I think you are able to see that. So this series of points that I have selected, 9 points, discusses about the information about humans, how they interpret the topics, and all this related text to topic. Okay, map of topics. So this is the area where I did the selection. So I will do it again. So I'm going to select this, and once I do the selection, you will see that five points have been selected, and you will see that contextually we will use the above map of news. If you click on this, you will see to each other with news the map of the other article. So the text which is related to the map of topics will get populated here. Okay, so I have shown you exactly what the Atlas can do, and before we go further, you have to get an access to Nomics account. So for that, you have to go and sign in. After you sign in, you will be able to get this kind of a dashboard. So you have to go to atlas.nomic.ai and then sign on from there. Okay, so there were a couple of challenges. So this particular service is not new. So it was introduced quite some time back. The challenge was when I first got the sign in, I was not able to get this dashboard for some time. So I was not able to create the projects, and I was also not able to get the API key. So you will get the API key after you click here, and this API key is what you will be using as you go into the discussion. And this API key is it can be changed, so you don't need to worry about it, and you can always change it. And the library that we will be using is called as, it is Python's own Nomic library. And here is a simple example of how the embedding is getting done. All these things are fine. So if you go here and if you look at the projects, whatever projects you are creating, all the projects will get created here. And another important point I wanted to highlight is there will be multiple maps that you can create. So as you build your vector stores, initially you will have lesser number of vectors. The text document, you will not have a lot of information. And as you add more documents, your vector stores will start growing. So this is what you see in this particular page where I have been building the vector stores. I'll be showing you how to do that in a couple of minutes. The point I want to highlight here is that all these things happen in matter of seconds. So there are a couple of settings I want you guys to understand. In the settings, if you click, you will see that maximum number of projects that is available for free is 50 projects is available for free, and the project data limit is 50,000 data points, meaning the number of data points that you have in each of the projects that you look here is in total should be less than 50,000 data points. I feel that with when you want to practice something, when you want to understand how the embeddings work, what is exactly happening inside the vector store, then I would really suggest that you guys try to upload the data into Atlas Nomics vector store, understand the topics, understand how it is distributed, and then you can actually move it to any of your vector stores. So I'll be discussing in detail why I am telling this in a couple of minutes. So with that, with that brief introduction, let me go back to the PDF. So here, whatever I have written here is basically whatever I have introduced, but there are a couple of other things that I wanted to also highlight. So scatter plot of multi-dimension embedding in 2-dimension, topics are populated, interact with documents, creating custom tags, all these points I discussed. So you can do vector search based on the queries. You can actually visualize AI models and think of possible route to debug. So this aspect is something new, and I would like to take a separate discussion on this particular topic and go a little deeper into ML neural networks and also how to visualize them in the coming videos. Work with various embedding models. So this is also one of the key points. Nomic by itself has an inbuilt embedding model. So if you're going to only use Nomics embedding model, it's fine. So you don't need to worry about how to embed using your own embedding models. But if you want, there is a process for that. I'll be following that process only. And multimodalities. So the data, the document that we saw in this case, in these examples, it is all text modality. So I have not embedded any image or audio or any such data. Only text I have embedded here. But what is possible is you can work with image, you can work with other data sets also, and you can make the embedding and you can store it in Nomics Atlas. All the above can be accessed online, as I already showed, and Python API and LangChain classes are also already available. So if you guys are from LangChain background, you can actually connect with LangChain with less amount of effort. So all these things are possible. And I believe that you have learned a thing or two from this discussion. So do leave a like and share it with others. Also, important point is share it with others, because most of us currently are facing this challenge that we know what is the large language model capable of. We know there is a context length challenge. Yes, even if there is going to be 16K, 32K context length models, there is going to be bigger data set that you need to work with. And the more bigger the context length becomes, you have to understand what exactly happens inside the vector store as well as inside the model. The more you understand the details, better you are in controlling the large language models. So with that said, I believe that I will add some value to your challenges. So do subscribe to my channel and you will get more information, not just regarding large language models. You will get updates on various other open source Python ecosystem libraries also. With that said, I would like to go to this particular collab notebook that I was already showing. So let us jump right into the discussion. Just a minute. Okay, so if you I already hosted the collab notebook in this projects folder. You can take a look at it. It is under the folder called as Exploring Nomic, so you can get the details there. And you guys must be already thinking, I have heard of this Nomic word somewhere. Where it is? Okay, Nomic is the team behind the GPT-4All models. So if you go and search in Google for Nomic, you'll be getting the GPT-4All model first. So if you guys have been following with my various videos, I have already discussed on GPT-4All models in the series of videos. Sorry about the disturbance. So here we see that I was discussing about GPT-4All models in my playlist. You can take a look at that. Nomic had been introducing various open source models already in the open source ecosystem. So let us now dive into the actual code. This is, as I already told, I'll be going through this code where the idea is I'll be using a text document that is already embedded in this code. I will not actually download anything, or I will not upload any text document. It is already included in this. This OpenAI key, we'll have to use it for creating the Atlas project. So this key you will have to get it by yourself by using your own account. So this key will not work for you guys. So I'll be deleting this key from my account. The point I want to make here is, once you this particular Jupyter notebook will take the text document, split it, and then embed it using open source Hugging Face embeddings, and then take that embedding and then load it into the Atlas Nomics database, and then allow us to do all the visualization and work with it. So this is what this entire Jupyter notebook is going to do. Let us start. So I am going to use the classes from LangChain for working with couple of ideas here. So first idea is to get the embedding function. I'll be using Hugging Face embedding class from LangChain, and I'll be using the default embeddings that is available with LangChain. So you can change this embedding model to any other model that you want. That also, if you are new to embedding sentence transformers and embeddings, take a look at the video that I've already shared on sentence transformers library. This is the first step. Second, this is the recursive character text splitter class that is created using LangChain again, and this class will be used for splitting the text. So first two functions have been created. Third, this is the first text document I'll be using, and this is from the Atlas documentation itself. So I'm going to take one of the documentation part, that is how Atlas works, and I'm going to embed it. This step is where I'm going to split this data that you saw just now into smaller chunks. So you see that once I split it, you'll see that I'm able to see the first part of the first element of this particular list. So splitter.split text will create a list of text documents or text snippets. After that, in order to load the data into the Nomics Atlas, you have to create a data structure, a dictionary data structure. For that, the dictionary data structure should have a text field and as an ID field. This ID field is mandatory. So keep this in mind when you need to load and load the embedding or load the text alone. You need to ensure that your data has got this ID field, and your data should be in list of dictionaries format, or it should be in a data frame format. Any of those only will work. So this is the place where I am creating the dictionary using text dataset. So this is text split is the list of text data. So this will be a list of such. Okay, let me actually show it for you guys to understand what is going on. So text split will be just a list, while text dataset on the contrary will be, okay, let me execute this because I have not executed that. So text dataset on the contrary will be a list of dictionaries, and in order to store it in the Nomics database, you have to use the list of dictionaries only. So you see it's a list of dictionaries. Now next step is we have to embed these text documents. So these text documents we have to embed. You are not going to embed the dictionary, keep that in mind. You are going to only embed the text documents here, but we use embed. So embed is the Hugging Face embedding class, Hugging Face embedding instance that I created, and I am going to use embed documents, and using this method I can directly embed all the list. I don't need to do it step by step or one text document at a time. I can actually give a list of documents and it will work. Most of the time when you are working with Collab Notebook and new libraries, what I do is I always try to come and hover on top of the methods, which will actually provide the type of inputs you have to provide, that you have to give to the function. So you see here, this is the text variable or the parameter, and it should be in the form of list. So they are giving it directly there. What should be the type of the parameter, and you see it is list with square brackets string. So it means you have to give, even if you are going to give single string data, it has to be as a list. So ensure that you understand these things when you are working with such libraries. Going down, so this is one of the data set that I was planning to work with, but then I realized, okay, let me do something with my own data set. So you can actually work with this data set also. This is from the example notebook that Nomic had shared. So you can take a look at this also. So here is where we actually start working with the Nomic primitives. So what we do is, first of all, we have to create, just a minute, let me actually move this little up, so that first we have to instantiate a Atlas project. So in order to create an Atlas project, you need to give a name. You need to mention what is going to be the unique ID field. So I was explaining to you guys that it has to have a ID field, right? So it especially doesn't need to be ID like this. So it can be of any other name. It can be of index, it can be serial number, but there should be an index field, and that index field should be mentioned in this unique ID field parameter. And modality, when we are going to choose, if you are going to provide your own embedding, in our case we are going to provide our own embedding, right? We are going to create the embedding using open source Hugging Face embedding model, and then we are going to load it manually by ourselves, right? For that process we have to say the modality is embedding. So this modality can be changed into various other modalities like text, image, and also various other new data points that you can think of. I'll be showing in the next video how to work with a couple of other data sets so you can understand a little better. So here, this is the Atlas project class that gets instantiated, and same way, like how you got the information for the method, the details of various parameters you need to provide for the class is also available. So you can take a look at that. So here you can see the name, the description, the unique ID field. They say it's optional, but do not let it be optional. It will be difficult for you to control. Then there is modality, there is organization name, is it public or not, the project ID, all those things you can provide. Most important point is this particular variable. So reset project if exists. So if you're going to work with the same project, and if you're going to change the data, and if you're going to update, if you're going to change the data, then use reset project if exists. But if you're going to update, there's a different process. So keep this in mind. If you're going to update, do not use this option. So keep this in mind, do not use this option if you're going to update. If you're going to change, if you're going to remove all the internal embeddings and put a new embedding inside the project, then use reset project if exists equal to true. Okay, so this is about the Atlas project. Next, once you create the project, what will happen is the project will get automatically created. So Atlas testing under organization Kamal JP. So if you go here, you will see that the Atlas testing project gets created. Or once that is done, what we can do is we can start adding the embeddings. The modality is already embedding. I already showed you, right? And here the embeddings have been already created. I also showed you how the embeddings got created here. After this, you have to use the embeddings directly, and you have to convert it into NP array, meaning it should be NumPy array when you are sending that embeddings into the Atlas Nomics database, and you have to send it along with the text dataset, that is the dictionary list of dictionaries. You have to send it that way only. Once you do that, the data as well as the embedding will get uploaded, and you will get the feedback that upload succeeded. And once you do that, now the data has gone and sat inside the model, inside the inside the Atlas database. However, it is still the topics or the map is not yet created. So to create the topics and create the map, you need to use something called as a method called as create index. So once you use this create index method on the project, so this is the project that you started, this is the project instance, you need to use create index method, and you need to mention build topic model equal to true and topic label field equal to text. So this text field is same as this text field. So you see that. So these things, these kinds of links are clearly explained in the Nomics Atlas documentation. You can visit that also, but I felt that I need to share these things because it can be a little disorienting. As the examples they are using there and the example that you will be using, as I always say, let us go back to the PDF for a moment. I always insist on practice, and the reason why I insist on practicing is that too, especially with your own data set and trying to do something totally different from whatever the documentation is telling, can help you to learn really fast, and also it can help you to learn to an extent where you can teach others. I believe that you like this way of learning and getting your hands dirty, or at least your computer's processor and hard disk dirty, and understand how the things work. So let us go back to the browser. Let's continue. So we have done a lot of things right now. So we have worked with the text data, we have split it, we have embedded it, we have converted the text data into a list of dictionary format, we have created the Atlas database and Atlas project, and we have pushed the embeddings into the, along with the text, into the Atlas database. And after that, we have created the index. So once you create this index, you will be given this particular link. So if you click on this link, it will automatically open the map. So create index method is the point where the maps are getting created. So this is something you guys have to clearly understand. Without that, the map will not get created. So the text data, the embeddings can be still there inside your project, but the map will not get created. So now you understood how the maps get created. I'm going to close a couple of tabs to get some, give some breathing space to my RAM. Next, so once your project is all done, so we see that now assume that you have a project already, this project is available, and you want to add some more additional information. So how are you going to do that? There were some of the challenges that I'll be sharing with you on that aspect. So the process is very same. Only thing is you have to start the instantiate the project by calling the existing project name. So you are not going to say like how you instantiated in the first time, that unique ID field and modality. You are not going to give these two parameters. Just give the project name. So it will load the existing project. Once that project is loaded, you can actually access the maps by using project.maps attribute. And this project.maps attribute is actually a list of maps. So the number of times you call the create index, that many number of maps will get created. So if I execute this project.maps, you will see that it is a list, and it is last in first out. So basically the top map is the most updated map. The earlier maps are actually pushed back into the list. So this is also one of the points that I wanted to highlight to you guys. Okay, let us go forward. Here, let me actually, I am just showing you a couple of ways where you can interact with the project. So before we start adding the data, I want to show you a couple of other information also. So once you create this project, once you load this project, you can actually get the data from the project using the IDs. So the IDs that you remember that we created in this location, the IDs that we created here, that IDs are going to be used for getting the data back. It is very similar to how you use select commands in SQL. You can use that and you will get the entire ID along with the text also. So this is what the purpose of ID is for. And this is something you guys have to observe. So we created this ID and we had this text with us, but this ID underscore was created by Nomic, Atlas database only. So let me zoom in a bit. I suppose that will be better. So okay, anyway, this particular text is not getting zoomed in. This ID underscore is going to be a challenge when you are going to load the new data. Let us continue. So I will tell you when it comes. Next, you can use map. So see, there are two variables. There is map, project.maps, and you need to select the index of the map. That will give you the map. Okay. And there is just a project, so that you can get it using name atlas.testing. So both have different methods and attributes. This keeping track of that initially can be a little bit challenging, as I was also facing it. So it comes with practice. So inside the project, you can get the data. Okay. And inside the map, you will be able to get the topics, you will be able to get the topic hierarchy, you will be able to get the topics metadata, all these things inside the map. So each map, so for example, if you go up, there are two maps. Each map will have separate topics, separate hierarchy, and separate metadata. So this is also you guys have to practice and understand. I'm not going to go deeper into that. I will go into that in the next video. Now the important aspect. So how to do the vector search? In case of other data stores, other vector stores, you would have there will be a method as usual for doing the similarity retrieval. So similar document retrieval. In same way, we have a similar document retrieval in Nomics Atlas also. But the way it is done is little bit different. So you have to manually go through this process. So you have to query. You should know what you are going to query. That is in text format. You have to embed it and convert it into NumPy array. And this particular, you see this particular list that is getting created. This list length should be less than 256. Okay, the embedding vector length itself can be anything. So that is not the point here. So what I'm trying to say is this took some time for me to understand. So if you are going to have query 1, query 2 like this, you can only send 256 queries maximum in a single go. So you cannot do more than that. So that is what this particular Atlas database accepts. Above that, it will not accept. So keep that in mind when you are working with it. And it should be in the list NumPy array format. It cannot be in a regular Python list format. It should be in NumPy array format. So for those who are new to Python, and when you are thinking that what is the difference between a regular list and a NumPy array, the difference is very simple. The NumPy array has various methods which can be used for calculating the matrix distances. It can be used for calculating the topics, and it has inbuilt optimization for such calculations. So it is very fast. But the list, the regular Python list, is not in such, does not have those capabilities. So that's why Atlas asks for NumPy array. So once you create a NumPy array of this query, you can directly send it to vector search using queries and the number of written documents. But understand this vector search is inside the embeddings. The vector search method is inside the embeddings, and this embeddings is an attribute for map. So the map that you create here by using project.maps number 1, so the embeddings is inside that. So that is how you can do the vector search. And there is a vector topic search also that will be taken up separately, but this is vector search. And once you do the vector search, you will actually get two information. So you will get the embedding of the query itself. This entire query will be embedded inside the just a minute, let me actually show you what happens. So let me click on this, it will open it. So what basically the vector search does is it will create this, it will take this entire embedded data of the query, and it will place it inside this map, and place it inside this map as a dot, and that dot location is what this is showing. Okay, this is not required for you, but it is better to understand what is going on. All you need is this data. Okay, this data is same as the IDs that you use here. So you remember I show you this get IDs. You can use that data and you can get the IDs. So if you take this list and if you use the get data, then you will know which documents are close to this query. So how Atlas works is close to how Atlas works inside the database, and also the answer. Atlas stores and transfers data using a subset of. So this is how you do the vector search. And you saw the difference here. We can clearly understand the process the embedding store takes for retrieving the documents, and you are in control of it. So this is one of the crucial things that I really liked about Atlas, and I want you guys also to experiment with, because most of the other vector stores, this entire process is actually very abstract in nature. You cannot visualize that easily, but now you can actually visualize what is going on. So for an example, this is a very big model. Let me try something else. So let me go back and let me open the earlier map, which is smaller. The map that I was showing just a moment back is actually a bit bigger and has more data. Here, if you see, let me click on this. So once I click on this topic, you saw the topic got the rest of the dots vanished, and now all the data that is available here is related to embedding. So if I go and click on this, you will see that it is talking about embeddings, and if they are in vectors, so the text is related to something related to embedding. This is the way how sorry for the disturbance. So this is the way how embedding inside the atlas is retrieved. Okay, so I have given you some brief understanding of what exactly goes on in atlas, as well as how you can visualize vector search and how you can get the data also. So this particular function, what it does is it takes the query, it takes the map, the atlas map that you are going to use. It is going to take the project as the parameter, and it is going to take the number of documents, and I'm going to send all these things in. And once I send this in, you can do a vector search on the query directly. Okay, so we will be using this function in a couple of minutes. Let us now do the second task that I was talking about. So this is a new document. This is a new text document that has been taken from Google's blog called Things Not Strings. So if you guys have been following my videos, you must know that already I have discussed about the same documents in Retriever. So if you go to this particular video, and if you have been following, I have been talking about LOTR, chef of all retrievers. So in this video also, I use the same documents, and I create the embeddings of the same documents in FAISS data store. So if you want to see how the documents are embedded differently in FAISS, you can take a look at that video also. It is for you guys to understand what happens between different vector stores. So once you understand the difference, right, you can learn it more fast. That is one of the advantages that I want to share with you guys. Let us proceed further. So the process I'll be following is same. So I'll be splitting the text, and I'll be creating the data set. So in this case, you see I am actually creating an additional field here. Why I am creating this is, so this is where I want you guys to understand. So initially when I showed you, when you are going to send the data into the Atlas Nomic database, this particular field is automatically created. This is not created by us. But once this field has been created inside the database, any new data that you are going to send in must have that field. So initially I was a little puzzled that how to create this field. Then I realized, okay, see, at the end of the day, this particular field has to be there, and it needs to be just empty. So it has to be a string, and it should be an empty string. And once you do that, you can actually push the data, push these documents into the database, Atlas database. So without this, you will get an error telling that this ID underscore field is missing. Okay. So we have understood how the data set is getting created, and we are going to just embed the documents using the embed function. And now what we are going to do is, so this is how to look at the schema. So you see the schema here. So you see the integer that is ID, the text that is our text data, and the ID underscore string. So this is something that I was talking about just now, and the embeddings field. And it talks about the field length. It is 768 vector length, right? And now you can do the vector embeddings, that is add embeddings. And once you do the add embeddings, you have to create the index again. So once you create the index again, that is when the additional map will get created, and that is when you will see the bigger map. So this map is smaller. So let me zoom out. Let me actually close this. Once you close this, then it will actually open up. Just a minute. Let me close this for a moment, and yeah, let me click on view online. So it will take a moment for rendering, and you see that compared to the previous map, this map is bigger, and this area is about knowledge graphs, and this area is about Atlas embedding documentation. And you see there's a clear demarcation, because the data and the meanings of things located in this area is completely different from what is located here. So this is also, once you start adding your own data, try that out. So what you do is this is about knowledge graph, this is about embedding, and you try something about LangChain. Take a documentation of that and try to embed it and try to load it and see where the documentation gets populated, and you will understand what is exactly going on in vector embedding in reality. So let us continue. And once you do that, and if you want to do anything with this particular map, you have to select that map. So I am selecting map 0. Why? Because as I already told, the new map, the new data that you create will be pushed at the top. So the maps will be in last in first out. Okay, with that said, so it's not first in first out, so it's last in first out, so keep that in mind. So once that is done, you can do the same process of working with the schema. You can create index, and then you can start the vector search. So here I am saying strings, not things. This is the query, and I am sending it through the vector search method function. This function has been created by me manually. I showed it to you just a moment back. So this function takes the query, embeds it in this particular process, and it then sends the query into the map that you are going to provide here, Atlas map, and then it gets the ID here. So it gets the neighbors and embeds, and we are going to take the neighbors 0. So why? Because neighbors by itself comes as a list. So we are going to take the first element of it, and then it will give a series of documents, right? So that series of documents, I am going to run it through the this particular for loop and get the text. So let me show you in action. What I'm doing is basically that if I click, if I send this query strings not things, it will actually print the IDs, the neighboring IDs which are close to strings not things. And these ID numbers 240, 159, 166, these IDs are close to strings not things, and you can see the text inside those IDs. So you can immediately see that this text has something related to the query. It is talking about strings, it is talking about all these things are talking about strings, and you see that they have given the details. Now if I take 15, I hope that it will work. Let us see. If I execute this, I might I'm getting an error because vector search is not defined, because I did not execute that. So let me go up and execute that for a moment, and that will also lead me to creating further challenges. So let me try that. So whenever you are working with Google Colab or Jupyter Notebook, this is one of the challenges, because most of the time you don't need to execute it. And if you miss any of the points or execution, then it will actually error out. So I will let you guys to, so here it worked once I created that method, and you see that now instead of showing just 5 documents, it is showing me 15 documents, and you can see how these documents are all linked together. And it's not just that, this strings not things is also showing me the information from Atlas documentation also. These things of understanding how the semantic nature of the embeddings work is very crucial. So here you can exactly see how the vector search works and what kind of text data is getting returned. And you can use this text data and you can send it to the large language models as a context. And you can do a lot of things with that. So here I am doing one more query where what is Atlas, and this particular text is all coming from the Atlas database only. And if I increase it to 25, so I just want to return more documents, and you'll see that it is returning me more documents. And excuse me, all these documents are from Atlas documents only, Atlas documentation data only. So this is how we work with Atlas database and Nomics Atlas database, and get benefit out of it. I believe that you had a good clarity on not just Atlas database. In this case, you understood exactly what is going on in embedding and vector search, and how to visualize the vector search. How to visualize the